Orchestration means automation that supports processes and workflows, particularly the provisioning of resources. So, orchestration lets us do things like scale up, scale down an application based on request. And that means assigning more resources to them or taking away resources when they are no longer needed. It also allows us to do things like auto-scale applications based on usage, so we can actually detect increase and decrease in the usage patterns and automatically scale up and down based on response. Orchestration also lets you do things like create self-healing systems, so we can detect unhealthy nodes in a load balanced pool, remove them from the pool, and automatically replace them with healthy nodes before users experience any problems. One of the great orchestration tools that's available here is the Docker Swarm. Docker Swarm is Docker's native orchestration tool, and it is created explicitly for the orchestration of Docker containers. Orchestration goes very well with Docker containers because the containers are lightweight and self contained, that could be spun up or spun down very, very quickly. Containers are very efficient to use alongside orchestration tools that control when and how they spin up and down. And containers tend to make orchestration easier. So if you want to do orchestration around your Docker containers, Docker Swarm is a great way to do so. Another very powerful orchestration tool is Kubernetes. It is called as a gold standard in the world of orchestration in DevOps. Kubernetes is open source and it uses an orchestration server to control the orchestration of your resources. Kubernetes is able to manage your containerized apps across multiple hosts so that you have a pool of resources that may consist virtual hosts, probably bare metal hosts, or even cloud resources. So Kubernetes is able to utilize that pool of resources to orchestrate your actual application containers and provision resources to them as necessary. Another important orchestration tool is Zookeeper. Zookeeper is an open source solution developed by Apache Foundation, and Zookeeper can work alongside Kubernetes. Zookeeper includes a centralized service registry, and much of its functionality is built around that concept. The services spin up and spin down, and they register themselves with a centralized service registry. And that is done in order to help the services locate one another through the service registry. So that means that the service registry will act as a center point for orchestration features. Another powerful orchestration tool is Terraform. Now, Terraform is a tool that's a brainchild of HashiCorp. Terraform combines orchestration with infrastructure as a code. Now, some people think of Terraform as more of infrastructure as a code tool or a configuration management tool, something a little more similar to Ansible. But Terraform is really built around the philosophy of orchestration. And that means that Terraform crosses both of these territories, but it's really focused on orchestration. Terraform works really well alongside other tools like Ansible, so you can use Terraform and Ansible together. It also works really well with AWS and it integrates with Kubernetes. So you can use Kubernetes to do high level orchestration and implement a little bit more of the detailed configuration within the Terraform scripts. So when you are looking at tools you want to use to do server orchestration, you do not necessarily need to choose between all of these tools. Many times you may want to use more than one because they can work all together with different tools handling different pieces of the big picture that is server orchestration. Now we know that server orchestration is a large and complex topic and there are different tools and there are several tools that can be used to do it. In this lesson you just had a brief introduction of some of the major ones, but you're definitely going to bump into more of these when you do some more research. So if you want to enter into the world of orchestration, I suggest that you go ahead and research about it and see how it actually works. The benefits of orchestration are incredible. and it's well worth doing research and learning what you need to find the tools that you need in order to do it well. DevOps and the cloud, although are not married to each other, but the practices of DevOps have been widely used in every cloud platform. So far in this course, we discussed about the practices and concepts and tools that are associated with DevOps. Now we're talking about how DevOps will contextually fit in the cloud arena. There's a very close relationship between DevOps and the cloud. It's important to understand that DevOps and the cloud, although are very closely related, but they're not the same thing. DevOps is a culture of collaboration between development and operations, and it can happen inside the cloud or outside the cloud. The cloud, in its simplistic terminology, means remote servers on the internet that offer services in place of locally hosted solutions on your premise in your data centers. You might have heard of people saying cloud is just someone else's computer. So, DevOps is a culture of collaboration that can happen with cloud or without cloud. The cloud means utilizing remote services in place of locally hosted solutions. Although DevOps and the cloud are not the same thing, the culture, the practices of DevOps are very useful in the world of cloud. DevOps and the cloud work alongside with one another. You can also say that they kind of grew up together, and in many ways, cloud services are built upon DevOps practices. Cloud services can also be a great tool for DevOps. And there are several cloud services that offer features and functionalities that will support DevOps practices and will support you in using the DevOps tools. We'll be talking more about this relationship, but in order to understand this further, we need to talk about different architectural stacks that you can find in the cloud. But before that, is there a stack in the traditional world? In the traditional architecture, you would be managing your own data centers in your premise. So you would start with the networking layer, the networking infrastructure. You have a storage infrastructure, and potentially you may have virtualization. And on each of the servers, you have an operating system, the middleware, probably the runtimes, databases, and applications, and the whole stacks that will require for an application to perform properly. In the traditional stack, you are responsible for managing and maintaining every layer of the infrastructure. So, with the traditional stack, you provide all of the infrastructure that is necessary in order to run your applications. Now, let's take a look at some cloud architectures. Well, the first type of cloud stack is infrastructure as a service that you know also prominently called as IaaS. Now, with the infrastructure as a service stack, someone else provides the low level infrastructure. So the cloud provider typically provides you with a bare operating system, and then you are responsible for being able to log into those machines and do any additional configuration beyond just a bare operating system. Certain examples of infrastructure as a service would be Amazon Web Services providing EC2 instances, Microsoft Azure virtual machines, and also containers. Google provides infrastructure as a service in the form of a compute engine. So, just to be clear, I'm not saying that Amazon, Microsoft, Google platforms are entirely infrastructure as a service. It's only these specific use cases like EC2 instances or virtual machines from Azure and containers and the Google Compute Engine, also called as GCE, are characterized as infrastructure as a service. Another type of cloud stack is platform as a service. Now, with infrastructure as a service, the cloud provider provides you with the bare operating system that you then have to configure. But with platform as a service, they provide you with a standardized OS, and then you deploy your data layer, your applications on top of that. You are only responsible for managing the application and the data. Some examples of platform as a service would be AWS Elastic Beanstalk, Heroku, and Google App Engine. Let's talk about another important aspect of the cloud architecture, which is software as a service. So, with software as a service, everything is managed by your cloud provider. You're not coding your own applications, but you're simply consuming an application that the service provider has given to you that is already prepared for use. You're not responsible for deploying or maintaining or running the application. You're only responsible to use the application. An easy way to understand this would be with the help of certain examples. Think about Gmail or Office 365. Now, these are categorized as software as a service solutions. So, if you're using Gmail, you do not do any engineering, you do not do any administrative work, you do not code, but you simply start using Gmail as a service via a browser sitting on your computer that has internet. Now there's another exciting model that we're going to talk about. It is called as function as a service, also called as serverless. Serverless is very different from the traditional application architecture. With serverless, everything is abstracted. You're not even deploying whole applications. You are simply deploying small, single purpose functions or code. Now, with serverless, it doesn't mean that there is no server. It's actually a misnomer, yeah? There's some kind of a server running in the cloud provider's data center. So it just means the term serverless just means that you do not have to think about the server. That layer is completely abstracted. You simply deploy the small single purpose functions and you pay for the compute resources that are used by your code or used by your functions. So you never have to think about servers or instances or scalability. It all just happens for you automatically. There are certain examples that I could talk about when it comes to serverless or function as a service is when it comes to Amazon, you got AWS Lambda. And Amazon has a larger AWS serverless platform that includes a few other features in addition to Lambda. In Azure, it's called as Azure Functions. Google Cloud, it's called as Google Cloud Functions. And all these three from different cloud providers are categorized as serverless or function as a service offering. Remember that in function as a service or in serverless computing, you do not have to worry about the underlying infrastructure. You just have to worry about your code and you push it to one of those serverless services provided by your cloud provider. All of these different types of cloud architectures take advantage of the DevOps tools and concepts. So whether you're doing infrastructure as a service, platform as a service, software as a service, or serverless, the tools in the DevOps world will help you enable and implement the DevOps culture.